All right, so we have the eighth class for sorts. Today we have rationalization of sorts. How do we rationalize sorts, and what does it actually mean rationalizing? First of all, this one is a rational number, and this is an irrational number. The process of making irrational number to become rational is what we mean by rationalization. Yeah, as the word implies, rationalization, making it to become rational. Okay, but mostly when we rationalize, um, it is often useful when we have a fraction wherein either the numerator or the denominator is the part that is irrational. Like we have here 1 over 2. 1 is a rational number. Root 2 is an irrational number. So if we decide to rationalize the denominator, meaning we want to make the denominator to become rational. That is the meaning of what? Rationalizing the denominator. We cannot have 1 and say, let us try to rationalize the numerator. We cannot have 2 and say, let us try to rationalize the numerator because it is already a rational number. When you say a rational number, is a number that can be expressed in the form A over B. Any number that cannot be expressed in the form A over B, where B is not 0, that number is what? Is an irrational number. If the number can be expressed in A over B, where B is not equal to 0, then the number is what? If we can express it in this form, the number is a rational number. If we cannot express it in this form, the number is an irrational number. Now we have 1 over root 2. 1 over root 2. We want to rationalize the denominator because the denominator is a rational number. It's a surd. Mind you, surd is just another way to say irrational number. Now, for us to rationalize the denominator, the only thing we do is by multiplying both the numerator and the denominator by the denominator. Suppose the denominator is just a single term and not an expression. So we have here root 2. So we say root 2 times root 2. Why this one is approved? Why this one is true? Let's say we have 2 over 3. And there are 4 different students. Student A will say, well, let me multiply up 4 and multiply down 4 again. Student B will say, let me multiply both the numerator and denominator by 6. Student C will say, let me multiply both the numerator and denominator by 10. Student D will say, let me multiply both the numerator and denominator by, let's say, 7. But guess what? 1, 2, 3, 4. Though this one chose to multiply both the numerator and denominator by 4, this one by 6, this by 10, this by 7, all of them have the same result. This will give us 12 over 18. This will give us 8 over 12. This will give us 20 over 30. This will give us 14 over 21. But the good thing is that 12 over 18 is 0.66666. It will not end. This again will give you the same. This again will give you the same. This again will give you the same. Why? Because if you simplify 8 over 12, it will give you 2.3. You simplify this, it will give you this. You simplify this, it will give you this. You simplify this, it will give you 2.3. And 2 upon 3 is 0.66666. Yes, it's a recurring decimal. All right. So it tells us that whatsoever we use to multiply the numerator and the denominator, it will not change the original value. But this is a surprise to you that not only 2 that is acceptable to use, Any number that you think, if you multiply the numerator and the denominator, will make the denominator become rational, it is acceptable. I hope it is clear. But the reason why we usually use the denominator, because it is the lowest of all of them. So 1 times root 2 is root 2. Root 2 times root 2 is 2. So now you can see that the denominator is no longer a surd. It is now what? A rational number. So we have rationalized the denominator. We have 1 over root 3. How do we rationalize it? We can say root what? Root 3 times root 3. 1 times root 3 is root 3. Root 3 times root 3 is 3. So the denominator is no longer a surd. It's no longer an irrational number. It is now what? A rational number. Why? Because 3 can be expressed in the form A over B. So that makes 3 a rational number. So let's go to number 3. We have 2 over root 5. We want to rationalize the denominator. But what do we have exactly there? We have root 5. So we say multiply by root 5, multiply by root 5. 2 by root 5 is 2 root 5. Root 5 times root 5 is 5. So the denominator is no longer an irrational number. It's no longer a surd. It is now what? A rational number. So here again, 2 over root 3. Multiply both the numerator and the denominator by this denominator. So this times this is 2 root 3. Root 3 times root 3 is 3. This is the result we get. Okay. Now the denominator is no longer a single term. It is now an expression. Well, in a situation like this, to rationalize this, we multiply the numerator and the denominator by the denominator. But when the denominator is a surd expression, what do? We have 1 minus root 2 here. We multiply both the numerator and the denominator by not this one, but by its conjugate. And the conjugate of 1 minus root 2 is 1 plus root 2. It's the same thing we do here. So 1 times 1 plus root 2 is 1 plus root 2. So remember, lesson 7 was about what? Was about, how do I call it? Conjugate. Yes. When you are multiplying a surd expression by its conjugate, it's so easy. So what do? The first multiply the first to give us 1. Because 1 times 1. We say minus all the time, always. Root 2 times root 2 is 2. So the top remains 1 plus root 2. 1 minus 2 is minus 1. But we don't want 1 to serve as a denominator, not even when it's minus. So we can assume that this one is like this. So plus divided by minus is minus. So 1 plus root 2. So if the minus affect this, minus 1. It affect this, minus root 2. So this is what we have. How about this one here? Well, we say 2 over root 3 plus 4. We want to rationalize the denominator. So we multiply the numerator and the denominator by the conjugate of the denominator. If we have root 3 plus 4, the conjugate is what? Root 3 minus 4. And again, root 3 minus 4. All right. So this multiply this will give us 2 times root 3, or we can write it this way first. This multiplying this, root 3 minus 4. Now, this and this, they are conjugate to each other. Multiplying them is just a one-line step. So root 3 times root 3 is 3. We say minus. 4 times 4 is 16. So at the top, we have 2 into root 3 minus 4 over 3 minus 16 is minus 13. This is also correct because I don't want to go through more steps. You will try this one for me so that we can do this one together. Okay, so we say y over 1 over x plus 2 root 5. Now we say multiply by x minus 2 root 5, x minus 2 root 5. You can see it, eh? All right. I would have made this one like, okay, no problem, no problem. So 1 times this is just this, x minus 2 root 5. So x times x is x squared minus 2 root 5 times 2 root 5. 2 times 2, 4. Root 5 times root 5 is 5. You see? 2 times 2, 4. Root 5 times root 5 is 5. So we say x minus 2 root 5 over x squared minus 20. So this is what we have. Thank you for watching. Don't forget to follow, like, share, comment. Also subscribe to the YouTube channel. See my next video.